Imagine sitting alone beside a radio telescope in the middle of the night. The sky looks silent. Then a thin line appears on your screen. It is narrow, powerful, and coming from somewhere above Earth. It lasts long enough to make you wonder whether somebody, somewhere, deliberately pressed a button. Then it disappears. Astronomers hear strange things constantly. Most turn out to be satellites, lightning, broken equipment, or someone opening a microwave oven at exactly the wrong moment. But a few signals survive the first explanations. Some repeat like clocks. Others release more energy in a millisecond than the sun produces in days. And one became so famous that a scientist wrote a single word beside it in red ink. These are 7 mysterious signals from space that scientists struggled to explain. Number 7. The Perytons. For years, the Parkes radio telescope in Australia detected bursts that looked disturbingly similar to signals from deep space. They were short, powerful, and spread across radio frequencies in a way that resembled fast radio bursts. Scientists called them Perytons, after a mythical creature that casts the shadow of a human. There was one major problem. Several Perytons appeared during daylight, and multiple telescope beams detected them at once. A genuine signal arriving from one point in the sky should not behave that way. Something nearby was fooling one of the world's most important radio telescopes. Investigators checked aircraft, lightning, and atmospheric effects. The mystery survived until researchers noticed that the bursts often appeared around lunchtime. That clue led them to 2 microwave ovens at the observatory. If someone opened an oven door before its timer finished, the machine's magnetron briefly released radio energy. Under the right conditions, Parkes heard that tiny leak as a cosmic explosion. The Perytons were not aliens. They were impatient astronomers heating lunch. But the discovery mattered. It proved that even a signal shaped like something from another galaxy can begin only a few rooms away. Number 6. The Lorimer Burst. In 2007, astronomer Duncan Lorimer and his student David Narkovic searched old Parkes telescope data for unusual pulses. Buried in observations recorded 6 years earlier, they found one astonishing flash. The signal lasted only a few milliseconds. Its lower frequencies arrived slightly later than its higher frequencies. Exactly what should happen when radio waves travel through a huge amount of ionized material. The delay suggested the burst had crossed space far beyond the Milky Way. If that distance was correct, the tiny flash had released an extraordinary amount of energy. Nothing like it had been clearly identified before. But there was only one event. It came from archival data, could not be repeated, and had been detected by the same observatory that later found the microwave-generated Perytons. For a while, scientists could not even be certain it was real. Then other telescopes began detecting similar bursts across the sky. The Lorimer Burst became the first recognized example of an entirely new phenomenon, fast radio bursts. We now know that FRBs are real and usually come from distant galaxies. Some are probably produced by magnetars, dead stars with extreme magnetic fields. But the Lorimer Burst itself has never repeated, and its exact source remains unknown. Number 5. FRB 121102. The first fast radio bursts looked like cosmic one-time explosions. That encouraged theories involving stars colliding, collapsing, or destroying themselves. Whatever produced a burst should not survive long enough to do it again. Then FRB 121102 repeated. After its first detection in 2012, follow-up observations found 10 more bursts from the same position. The source had survived. Later campaigns recorded hundreds, then more than 1,000 pulses. Sometimes it became extremely active, firing repeatedly within a single hour. At other times it went quiet. Astronomers traced it to a small dwarf galaxy billions of light-years away. Near the burst source was a persistent radio object, and the signals passed through an environment with an enormous changing magnetic field. The source seemed to live in one of the most violent neighborhoods imaginable, perhaps near a massive black hole or inside the remains of a recent supernova. A young magnetar is the leading suspect, an ultra-dense stellar corpse with a magnetic field strong enough to twist matter and release colossal bursts of energy. But magnetars do not yet explain every detail. FRB 121102 transformed a single mystery into a larger one. If some fast radio bursts repeat while others appear only once, the universe may be producing similar signals in several completely different ways. Number 4. BLC-1. In April 2019, the Breakthrough Listen project pointed Australia's Parkes telescope toward Proxima Centauri, the nearest star beyond the Sun. The system contains at least 2 known planets, including one roughly Earth-sized world orbiting in the star's habitable zone. Inside the data was a narrow radio signal near 982 MHz. It appeared only while the telescope was looking toward Proxima. Its frequency drifted gradually, as though the transmitter or receiver might be moving. Those are exactly the kinds of features SETI researchers search for when looking for technology, rather than natural cosmic noise. The candidate was named Breakthrough Listen Candidate 1, or BLC-1. For a moment, it looked like one of the most compelling artificial signal candidates ever found. But extraordinary signals receive brutal testing. Researchers searched nearby frequencies and discovered dozens of weaker signals with similar shapes. The pattern matched electronic interference created when several human-made frequencies mixed together. BLC-1 was not a message from Proxima Centauri. It was a complicated local echo of our own technology. The disappointment came with a useful lesson. A false signal does not always look obviously false. It can drift, appear in one direction, and imitate nearly every feature scientists expect from a distant transmitter. Number 3. The Galactic Center Radio Transient. While surveying the center of the Milky Way in 2020, Australia's ASCAP telescope found something that did not fit any familiar category. Its catalog name was ASCAP J173608.2-321635. A coordinate so awkward that astronomers informally called it Andy's object. At first it was invisible, then it became bright in radio waves, faded and returned. ASCAP detected 6 signals over 9 months. No visible light object appeared at the same location. Searches in infrared and X-rays found nothing convincing. Even the Parkes telescope initially failed to hear it. When the more sensitive Meerkat telescope finally detected the source, its behavior changed again. Earlier episodes had lasted for weeks. This time, the signal vanished within a single day. The radio waves were also unusually polarized, meaning their vibrations were strongly aligned. That can indicate intense magnetic fields. But the source did not behave like an ordinary pulsar, flaring star, magnetar, or binary system. It came from the direction of the crowded galactic center, where dead stars, black holes, hot gas, and magnetic structures overlap. That makes the region full of possible explanations and extremely difficult to untangle. Scientists know the signal is real. They still do not know exactly what produced it. Number 2. The 18-minute beacon. Most pulsars spin in seconds or fractions of a second. Their radio beams sweep past Earth like lighthouse beams, producing fast, regular pulses. In archived data from the Murchison Wide Field Array, researchers found a source that seemed to follow the same basic idea at an impossible speed. GLEAM-X J162759 produced powerful radio flashes roughly every 18 minutes. Each active pulse could last between 30 and 60 seconds. For a few months in 2018, it became one of the brightest low-frequency radio sources in the sky. Then it vanished. The timing suggested a rotating object inside our own galaxy. Its polarization indicated an organized magnetic field. One possible explanation was an ultra-long-period magnetar, a dead stellar core rotating far more slowly than normal radio-emitting neutron stars. But according to standard models, an object spinning that slowly should not generate strong radio emission. It sits beyond the theoretical boundary where the mechanism is expected to shut down. Either astronomers had found an unusual type of magnetar, or their understanding of how dead stars create radio beams was incomplete. The source has not behaved like a normal clock since. It flashed, announced a new class of object, and faded before scientists could study it in every wavelength they wanted. Number 1. The WOW signal. On August 15, 1977, Ohio State University's Big Ear radio telescope detected a narrowband signal during a search for extraterrestrial intelligence. It rose and fell over 72 seconds, matching the time a fixed point in the sky would pass through the telescope's beam as Earth rotated. Computer printouts represented signal strength with numbers and letters. The sequence for this event read 6EQUJ5. When volunteer astronomer Jerry Eamon saw it, he circled the characters in red and wrote, "Wow," beside them. The signal was strong, narrow, and close to the frequency emitted by neutral hydrogen, a scientifically important part of the radio spectrum. It did not resemble ordinary broadband noise, and it appeared to come from the direction of Sagittarius. Big Ear had 2 receiver horns. A persistent source should have appeared again several minutes later when the second horn swept across the same position. It did not. Follow-up searches returned to the region again and again. The signal never repeated. Explanations have included human interference, a passing comet surrounded by hydrogen, a natural astrophysical source, and an artificial transmission. None has been confirmed well enough to close the case. The telescope itself was dismantled in 1998, leaving one famous strip of paper and a signal that humanity heard only once. These 7 signals reveal the hardest part of listening to the universe. A telescope does not label what it hears. A microwave oven can imitate deep space. Human electronics can imitate alien technology. And a dead star can behave in ways that existing physics says it should not. The careful explanations are not failures. Every false alarm teaches astronomers how to recognize the next real discovery. Yet the unexplained signals remain important too. They mark the places where nature is doing something our current categories cannot fully describe. Which mysterious signal did you find the most unbelievable? Let me know in the comments. If you enjoyed today's video, leave a like and subscribe for more entertaining videos about strange history, bizarre science, psychology, mysteries, and unbelievable true stories. Thanks for watching, and I'll see you in the next one.